Take a look at this terminal window. It's fully interactive, it tracks your score, and it responds to your inputs in real time. This is a complete number guessing game. You don't need a degree in computer science or advanced calculus to build it. We are going to write this entirely from scratch. All you need is an environment to write code. Professional desktop editors like Microsoft's Visual Studio Code are completely free to download and use. If you prefer not to install anything, cloud-based notebooks like Google Colab let you write and execute Python directly in your web browser. Over the next 5 minutes, we will use these tools to write a working game. You are going to step out of the role of a standard software consumer and write the core logic yourself. Python has a massive library of pre-written code files called modules. These give us extra tools that aren't loaded into the program by default. We need unpredictability for our game, so we will start by typing import random to bring in Python's random number generator. This diagram illustrates our next step. We declare a variable named secret, and we assign it the value of random.randint, specifying a range from 1 to 100. The computer rolls the virtual die and locks that number into memory. Next, we set up a variable called attempts and assign it a value of 0. This acts as our scoreboard. To keep the game running after a single guess, we write while true. This creates an infinite loop, telling the computer to repeat the indented code below it forever. Look at this warning. If a loop runs endlessly without a way out, it will eventually consume your system's resources and crash the program. We have to build an escape route into our code, usually with a command called break. By defining our starting values and launching this repeating cycle, we turn a single passive text into an active, continuous game state. Everything that happens inside our loop must be indented. This spacing is a strict rule in Python that tells the computer exactly which lines belong to the repeating cycle. Inside the loop, we type guess equals input and add our prompt text. This built-in function halts the program and waits for the player to type something on their keyboard. There is a catch here. The input function always captures keyboard strokes as text, a string of characters, even if the user types a number. The computer cannot mathematically compare the word 50 to the integer 50. This diagram shows how we solve the problem using typecasting. By wrapping our input function inside int, Python automatically translates the player's text into a proper whole number. Now that we have a valid number, we update our score by typing attempts plus 1. This shorthand adds 1 to our total for every guess made. By converting the text into an integer, we successfully bridge the gap between unpredictable human keystrokes and the strict mathematical logic our game requires. Now we evaluate the guess. We start by writing if guess equals secret to check for a perfect match. Notice the double equal sign. A single equals assigns a value to a variable, but double equals asks a question. Are these two values identical? If they match, we print our victory message. By formatting it as an F-string, we can insert our final attempts variable right into the middle of the text. This flowchart illustrates our logic path. Once the victory message prints, the program hits our break command. This immediately kills the infinite loop and safely ends the game. If the guess is incorrect, the program moves down the chain. We write an elif, short for else if, to check if the guess is less than the secret number. If it is, we print too low. Finally, we add an else statement. Since a number can only be equal, lower, or higher, we don't need to write out the final condition. If the data reaches this point, we just tell the program to print too high. Together, these statements map out every possible scenario, instructing the computer exactly how to respond to the player's inputs. Let's run the code. The terminal prompts us, and we will intentionally guess 90. The program evaluates it, hits the else branch, and prints too high. Next, we try 10. The elif condition catches it, correctly responding with too low. Finally, we input the correct number. The if statement registers the match, prints our exact attempt count, and triggers the break command to close the program. Now it's your turn. Open your editor, type out this code, and change the random.randint maximum from 100 to 1000 to increase the difficulty. You just used variables to store data, loops to maintain a state, and conditional logic to make decisions. You now have the foundational skills required to engineer real software.